In this video, I introduce detoxifying language models with context distillation. The unpredictable behavior of large language models and their potential to cause harms to users limit their deployment in real-world settings. To reduce the risk of large language models, one effective method is to introduce in-context learning into large language model prompts. Context tokens containing natural language instructions to describe the task can improve the zero-shot performance of fine-tuned large language models. Context distillation internalizes context tokens within language models to help model perform complex tasks by training student language models to learn from the output of the teacher models. Here is a context distillation framework, this teacher model and this student model. Output of the teacher model is used as a target to train the student model. In this way, the context in the teacher model is distilled into the student model. The context token is designed to minimize the frequency of toxic output generation from the teacher model. For example, starting with a simple context token like don't use any harmful language while completing the following sentence. We analyze the cases of inputs where the model didn't comply to the instruction, and then augment the token to address these cases, followed by repeated analysis and augmentation until the improvement between the iterations start to plateau. Eventually, we end up with a detailed context token with substantial length, as shown here. This is teacher model and this is student model. Adversary prompts are used to provoke offensive response generation. This is a prediction from a teacher model. This is a prediction from the student model. Output of the teacher model is used as a target to train the student model. The next step is to internalize the context token created in the previous steps into student models. While making inference on the training data, the prompt is concatenated with the context token only for teacher model. The output logs then go through a softmax layer with a preset temperature to produce the soft labels for each output, from which binary cross entropy loss between the student model and the teacher model is computed. The backup propagation is applied to only the student model on this loss to distill the context token. Use the context token. Don't use any toxic, insulting, profane, or sexually explicit language while completing the following prompt. The student model is T5 base, and the teacher model is selected to be T5 base with 76 million parameters, T5 small with 247 million parameters, and T5 large with 770 million parameters respectively. Here is a proportion of toxic output from the context distillation for baseline teacher model and student model. For more details, please check with these references. Thank you. Bye.